Let me disarm you. I'm not trying to own you. I just wanna.
Hi guys, my name is Nako Nakatsuka. I'm a fourth year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. So when we talk about a gas, we use its partial pressure and this equilibrium constant that is denoted by Kp instead of Kc. So as an example, let's do calcium carbonate, which is a solid, going to calcium oxide, which is also a solid, and carbon dioxide, which is a gas. So as we said before, these solids are not going to be involved in the equilibrium constant equation. So the Kp in this scenario is going to end up being the partial pressure of carbon dioxide because that's the only gas that's here. So when we talk about partial pressures, what we can do is use the gas law, which I think you've seen from high school chemistry, and the equation for that is PV equals nRT, where P is pressure, V is volume, N is the number of moles of gas, R is the gas constant, and T is temperature. But I'm not going to get into too much detail about this right now, but we can rearrange this to become P equals N over V RT. And then if you look at this part, this is moles per volume, such as, let's say, liters. So this is equal to concentration. So we can actually rewrite the pressure as concentration multiplied by RT. So often K, just big K, equilibrium constant in general, can be used to represent both Kc or Kp, depending on whether you're looking at the equilibrium constant for aqueous solutions or gaseous solutions. Okay, so now what does the equilibrium constant K tell us? Well, remember that we're going from reactants to products. And that K represents the concentration of the products over the concentration of the reactants. What does this mean? If K is really large, so let's say K is greater than 10 to the power of 3, then the equilibrium formation favors the products, where the equilibrium is shifted to the right. The reason why we can get this is because of the relationship between the products and the reactants concentration based upon this ratio. So if the value of K is very large, that probably means that the products, the concentration of the products is very large. The equilibrium favors this formation, and so it's shifted to the right. On the other hand, if K is small, so let's say K is less than 10 to the power of negative 3, then that means that if we look at this K value and it's small, the concentration of the reactants must be bigger. And that means that the denominator is greater, you're dividing by a larger number, and you're going to get a smaller value for K. So this means that in this case, the reactants are favored, and so the equilibrium shifts to the left. So at the intermediate values of basically K is approximately between 10 to the negative 3 to 10 to the power of 3, then neither R nor P are strongly favored. So basically, as a rule of thumb, if K is greater than 10 to the power of 3, then it shifts towards the products. If it's less than 10 to the power of negative 3, it shifts to the left, and any K value between those two numbers, oftentimes neither favors R nor P.